So hello again from my screen. We talked about arrays last time, and we talked about how in the usual variables, we can only store one value in one single variable. So our variables are basically containers for different types of values, like characters or integers, floating numbers, doubles, strings, etc. So we started talking about arrays, and arrays basically allow us to store more than one variable of the same data type in a single array. So we talked about integer arrays, talked about floating arrays, and today we are gonna talk a little more about character arrays, since we did not mention them last time, and then we're gonna talk about something really, really fun. So as we mentioned, arrays are zero indexed, meaning we start from 0 and we end at size -1. So for example, if we have an integer array of 10 different elements, like we have 10 different elements in one single integer array, the index of each element starts from 0 and then we go up to 10 - 1, which is 9. And that works for every single data type. And that's basically what we're going to be following in our journey in C++. So we also talked about for loops and how for loops is the process for us to access specific elements in the array. And all we have to do now is practice a little more on arrays. And we're going to start with very, very simple problems. And then slowly we're going to progress and try to solve more difficult problems. So we talked about floats, we talked about integers. Now we're going to be talking about character arrays. So for example, I want us to declare a character array. And as you remember, CHR or char or char, whatever you want to call it, is how we declare character variables. So we declare our data type and we want to call our variable letters, for example. And I want to give it an initial size of 5. Okay. And by the way, if you already declare the values here, you don't really need to include the size, but I would always prefer we have the size clear, because sometimes, like we mentioned last time, we don't necessarily always know the array contents, but we always have to give the array an initial value. So for now, I'm going to say that the size of our array is 5, and I'm going to give our array different letters. Okay, these are just random letters. And the last one's going to be H, for example. Okay, so it's very simple. As we mentioned, arrays are 0 indexed. So T is going to have an index of 0. R is going to have an index of 1, 2, 3, and 4. So we stop at 4 since we have 5 array elements. Okay, so I want you to help me find the vowels. I want us to try to count the number of vowels here. So let's actually increase the size of our array and add 2 more vowels. Okay, so we know that vowels are A, O, U, I, and W. Oh no, I not W, I said U. So it's A, O, I, U, and E, right? So, and some people include Y as well. So I want us in this letters array, I want us to find the number of vowels. Okay, so what do you think would be our first step to finding the number of vowels? I'm going to help you out and I'm going to include a counter. Okay, so I'm going to say integer counter and I'm going to give it an initial value of 0. And now I want you to help me. What do you think? We basically need to access each and every index and we want to check. If the index is A or O or E or I or U, then we want to increase the counter by 1. So in this case, we have to get 1, 2, 3. 3 vowels. So what did we say? How can we access the array elements without having to write them manually? Do you remember?
We need to use a for loop.
Exactly. So we need to use a for loop. Okay. And what do I include inside the for loop, Yasmin? What do you think?
Int I equal to 0.
Hmm?
Okay, I less than 7.
Exactly.
I plus plus.
100%. Awesome. So we're done with the first part. So now we want to identify whether the element that is in the letters array is a vowel or not. Okay? So what do you think would be our next step? And I want you guys to help me. I stopped giving you hints. What do you think? Decide whether the element is a vowel or not. What do you think? Any ideas? So if it's a vowel, and I give you a keyword, if the element is a vowel, then I want to increase the counter by 1. It's very similar to to many examples we actually did before. Very similar. Yeah.
We use several if statements.
Okay, so we can use that, but what would be a shortcut? Do you remember the Boolean operators that we took that are or and and? Do you remember them?
Yes, we can use them.
Exactly. So what do you think?
If letters I.
Perfect. What do you think? So how do we determine whether the letter is a vowel or not? So I'm going to give you a hint. We're going to be using 5 statements.
Okay. Usually when we use numbers, we say equal equal. But concerning chars, I wanted to ask, do you also use equal equals, or do you use dot equals?
If we use equal equal, we can use equal equal here. Perfect. So we can use equal equal. It works for every single data type. All right. And that's why I wanted us to practice on characters as well, because we've been practicing on integers and float, and we didn't give characters the attention. So what do you think we would have to include here? Also, should I include single quotes or should I include double quotes in this case, since we're comparing characters?
Single.
Exactly. So if letter I, indicating that if this element is equal to A, for example, and then I have to include more.
Yeah. Or.
Or, perfect. Or.
Or E, or I, or U.
Exactly. Yeah, 100%. So all we have to do is simply have an or between each and every statement. So if it's, so I'm going to fix these, of course. If it's A or O, let's fix these real fast. So I copy pasted just for sake of efficiency. A, U, O, E, and I. Okay? So if it's if the element in the letters array, and it's supposed to be letters, or I can just simply remove the S over here. If the element in the letter array is A or O or U or E or I, it means that it's a vowel. And we want to count the number of vowels inside the character array. So what would be our next step? I'm going to open and close curly brackets, and then I want you to help me over here. A simple step. What do you think?
Counter plus plus.
Counter plus plus.
Perfect. Counter plus plus. Okay. It's a very, very similar code. But the only difference is the fact that we have a character array here and not an integer or a float or a double. And we are comparing characters to the elements in the character array letter. So I want to display the counter to the user at the very, very simple statement, which is basically a cout statement, right? What am I trying to display to the user? Counter, exactly. So we can just leave it like that, or I can just say number of vowels in the array. And counter. So it's supposed to print out 3, since we have E, A, and O. Okay, so let's try and run our code and see what it gives us. It's taking a little bit of time. Okay, I'm gonna try to copy our code and refresh. No, okay. It's gonna connect in a bit. Sorry for the inconvenience. Okay, so all I did was copy paste the code, and we're gonna see what the code would give us when we run it. So perfect, our code is working. The number of vowels in the array is 3. So what if there were capital letters inside the letter array? What do you think? What if we had A? What if we had U? Oops. It's just one extra simple step. What do you think? Very, very simple step.
We should add them in the or, like complete.
Exactly. Yeah, 100%. That's all we have to do. Simply add the letters. You can also add another if statement, but it's not that necessary since we have one ready. So all we have to do is include all the letters and we're good to go. So I'm not going to go through all the letters. All you have to do is simply include them in single quotes and include this operator, which is the or operator between each and every element. Okay, so this is for characters. I want us to solve one more question. So I think, do you remember when we talked about, so I'm going to delete this for now. This is a very simple program. All we did was simply compare the elements in the array to the vowels, and we increased the counter accordingly. But do you remember when we talked about the ASCII table? And do you remember when I showed you this huge table, which of course you do not need to memorize? But the thing about ASCII, or the thing about the ASCII table is the fact that each character, for example, has an equivalent decimal value. So with A, lowercase a, we have the decimal value of 97. However, with uppercase A, we have a value of 65. And with B, we have 98. Uppercase B is 66. So the difference between each and every one is one decimal value each. Okay? So we keep on going and going and going. And every single character on your keyboard and every single button on your keyboard has an equivalent decimal value in the ASCII table. Okay? But who can tell me the difference between lowercase a and the uppercase a in the ASCII table in regards to their values? So what's the difference between uppercase and lowercase? What do you think? So 97 minus 65 is 32, right? So for example, the difference between lowercase b and uppercase b is 32, since 98 minus 66 is 32. And between C and uppercase C, it's 32. You have the difference between 99 and 67, and so on and so forth. But the thing that we need to understand and the thing that we need to know is definitely not all these characters. Don't need to memorize these characters, but it is the process for us to know the difference between the uppercase and lowercase and uppercase characters. And that's something we're going to be using right now, and we're also going to be using it in a couple of other examples. So I want you guys to remember, before we start solving, I want you guys to remember that we have A, lowercase letters in general, but starting with A, has a greater value, has a greater decimal value than the uppercase A, okay, or the uppercase letters. And the difference between both lowercase and uppercase is 32. And the thing about programming, the thing about C++ is that, for example, if I want to see out A, okay, see out A, obviously. But if I wanted to see out a lower uppercase A, then simply say A, uppercase A plus 32, okay? Now, of course, normally you can't add a character to a number. But here what we're doing is that we're adding 32 to the ASCII, to the decimal ASCII value of uppercase A. Okay, so I want to show you what the compiler would give us, and it's something that we're going to be using. So here we have A and 97. And 97, if we go back to the ASCII value, go back to the ASCII table, 97 is a lowercase a. Okay? And actually, if we want to, for example, and this is called casting, we're not going to be really using it. But if we want to print this as a lowercase a, I can cast it by adding 2 parentheses and saying CHR. We're not going to be really using this, but let's give it a shot and see. So first it printed 97. Now it's supposed to print a lowercase a, and I don't know why it's taking too long to run. So there you have it, A and A. And we're not going to be needing to cast it, okay? Because we are, here we are not saving these values in variables. But for example, if we saved character alphabet, we saved A, uppercase A in alphabet, and we printed alphabet, it's going to give us the same thing but without casting it, because we already declared that the value, that the data type of alphabet is character. So if I want to print alphabet as a lowercase a, which in this case is an uppercase a, we stored uppercase a in alphabet, it's going to print a lowercase a because, oh, sorry, it's going to print a lowercase a when we cast it, but in this case, since we're just giving the value of, we're just actually printing out the decimal value of that specific ASCII character. But if we wanted to print lowercase a, we can cast it. But in this case, in the examples that we're going to be solving, we're not going to be really needing to cast anything in order for it to print out whatever we wanted to print out. But in this case, apparently we have to cast it, and that's totally fine. But in the examples we're going to be doing, we're not going to be really needing to cast it. So I want us to work on something. So for example, we have a character array, and we're also going to call it alphabet. And we're going to give it a bunch of different alphabets, a bunch of different letters. So for example, I'm going to give it A, B, and C. And then I'm going to give it some lowercase alphabets, N, for example. And I want us to write a program that helps us print out this entire array. So we have 5 elements in here, but I want us to include a chunk of code that would help us print out all these elements as uppercase elements, as uppercase characters. So we have the first 3 ready, but what about B and N? Okay, I want us now to write our code. So since we're used to it, we're gonna write for integer I equals 0, I is less than the number of elements, which is 1, 2, 3, 4, 5. We're working with fixed elements right now, and I plus plus. So I want us to write the code that basically identifies whether this element in the alphabet array is a lowercase. And if it was a lowercase letter or a lowercase character, I want you to print the uppercase, let's say version or uppercase of that letter. So here I wanted to print A, B, C, B and N, but B and N have to be uppercase. And since we mentioned here in the ASCII, upper have a lower decimal value than the lowercase characters or letters. So here we have to switch things up. So in order for us to print the lowercase, we have to add 32. But if I wanted to print if I wanted to print a lowercase letter as an uppercase, what do you think I should be doing? I'm gonna help you out and include an if statement. And the goal of this program is to simply identify whether the element here is lowercase. And in the case that it was a lowercase letter, I wanted to print it out as an uppercase letter. Okay? So what do you think? I'm gonna help you out. If alphabet I equals, oh, sorry, no. It's something else in this case. What do you think? If it's lowercase, I want it to print as uppercase. Any ideas? We're gonna have to compare. That's a hint.
We compare it using the decimals you talked about.
Okay, so it does have a decimal value, but now I want to decide. So first, let's go step by step. I want to declare whether elements or whether this specific element in the alphabet array is a lowercase element from A to Z. Okay, so first I want to understand, I want to basically tell the compiler to check whether this element is a lowercase alphabet letter, whether it's a lowercase letter. What do you think? So we go from A to Z, okay? So if it's between A and Z, I wanted to do something, but for now, let's focus on that. How can I identify whether the element is from A to Z, lowercase a to lowercase z? Something that has
greater or equal to 97.
Okay, we can say 97, but for now, since we're working with characters, okay, I'm gonna go with
A.
Perfect. Okay, so if it's between if it's A or greater than A, we have to set a specific range, because if you don't set a specific range, it's gonna go through every single character that is greater or equal to lowercase a. Okay, but we have to set the range, and the range is from A to Z, lowercase a to lowercase z. Okay, so what do you think? How do we exactly set the range?
And.
Perfect. And
alphabet I is less than or equal to Z.
Absolutely, 100%. So here, what we did was we're basically just checking. For now, we're just checking. So is alphabet I equal to A or greater than A? And alphabet I is less than or equal to Z. So it's going to go through A, B, C, D up to Z, but lowercase in this case, since that's what we're declaring. And as I mentioned, if we left it like that, it's going to go through the entire ASCII table. It's going to go through the entire, well, not the entire ASCII table, but every single value, every single element or character that is greater than A, okay? So I think I kind of confused you with the decimal value. So in this case, we're only going to be using the decimal value when we want to, let's say, manipulate the results, which we are going to be doing right now. So all I want you to know with the decimal values is that the difference between a lowercase letter and an uppercase letter is 32. And an uppercase letter is always greater than, a lowercase letter is always greater than an uppercase letter, okay? So that's all I want you to know for now. I don't want you to be very confused with the decimal aspect, okay? But for now, we're done with the first step. So we're checking if the element in the alphabet array is equal to A or greater than A, but is also less than or equal to Z, I want to capitalize it, okay? And this is when we can manipulate the whole entire situation with using decimals. So since capital letters are less than lowercase letters, what do you think I should be doing over here? It's going to be the opposite of what we did a couple of minutes ago. I have to manipulate the elements. So alphabet I is something. What do you think?
Minus 32.
Perfect. Minus 32. Exactly. Since capital letters are less than lowercase letters, in this case, we have to decrease 32 from the element. In this case, B would be a capital B and N would be a capital N. Okay? So
But
I want
sorry, but wouldn't this give us a numerical value?
So here's the thing. We're going to test it and see. And we're going to check together. Okay? So it did give us a numerical value a couple of minutes ago, but we're going to test it now and see what it gives us. Okay, so I'm going to see out alphabet I, and I'm going to end the line just to organize the elements. Okay, so let's see what it gives us. Oh, oops. I did not write alphabet in the right way. Alphabet, okay, awesome. So here in this case, it did not give us a numerical value, okay? It did give us a numerical value before because we did not cast it and we did not have it, let's say, in an array or compact in an array. But in this case, it's going to be giving us character values, but it's going to be giving us, let's say, the character equivalent to the decimal in the ASCII table. So that's why I didn't want you to worry that much. And you don't always need to cast it, all right? But since here we're working with an array and we are, we're simply just converting, all we have to do is see out there. You do not need to cast it here. You do not need to include the open bracket car. Sometimes it might give you the decimal value, but in this case, since we're working with arrays, it's not you're not going to really worry about casting right now. Okay. So I'm sorry if I confused you about the casting and about the whole entire process, but for now, just worry about the difference and just focus that and just know for a fact that the lowercase characters or the lowercase letters are always greater in value than the uppercase letters, okay? So we're gonna be solving some more questions on that. And so now we know that lowercase letters are greater in decimal, they have a greater decimal value in the ASCII table. And the difference between an uppercase letter and a lowercase letter is basically 32, okay? So we're gonna be working on more examples just so you don't end up getting a little confused because sometimes it does get confusing since we're adding a decimal value to a character, which is unusual. But here, it's basically just gonna convert it to a character instead of a decimal. Okay? So let's start working on this code forces question that I actually wanted us to solve. And it's actually very, very simple. It's very simple to what we did right now. And then I want us to move on to something else. So here, the question is word capitalization. Okay? Capitalization is writing a word with its first letter as a capital letter. First letter only. Your task is to capitalize the given word. Note that during capitalization, all letters except the first one remains unchanged. Okay, so we're only working with the first letter. So the input here, a single line contains a non-empty word. All right, this word consists of lowercase and uppercase English letters. The length of the word will not exceed 10 to the power of 3. Okay? Output the given word after capitalization. So, I wanted us to start with this question as an introduction to what we're going to be talking about right now. So here, we are getting a string, right? We're basically receiving a string as an input. So it's a little different than characters. We're receiving a string. Sorry. But when you think about it, a string is actually very similar to an array, right? Since a string is basically plain text that consists of multiple characters. So here, a string can basically act as if it's an array. So for example, if I wanted to remove all of that, and I wanted to say string name, and give it, since double quotes, since we're working with strings, I'm gonna remove that. And I wanna give it the name Kathy. It's very, very similar to the concept of an array. So K will have an index of 1, A will have an index of 2, and then, 1, and then T will have an index of 2, H 3, Y 4. It's basically the same exact concept, okay? And that's the thing about strings, is that they're actually very, very similar to arrays. But in a string, we only have one specific value. So in this case, I called my string name and I gave it the value of Kathy. Okay? So here, we're also going to be talking about specific functions. Now, functions may seem like a new word, and we will be talking about functions later on in the course. But we will be talking about functions that would help us solve questions like word capitalization and other a little more difficult questions. So I'm going to start with the first function that would help us with word capitalization, and then we're going to move on to different questions. Now, the first function I want us to talk about, and it's something that actually has been mentioned before, which is called the length function or the size function. So length and size have the same, let's say they have an equivalent role here in this case, which is basically to return the number of characters inside a specific string. So for example, with string name equals Kathy, if I want to see out the number of characters inside this specific string, all I have to do is say name, which is the name of the string, dot size or length. We can go with length for now. And open to parentheses and see out the, this function will basically see out the number of characters inside this string. So all we have to do here for the length function is simply include the name of the string, dot length, open to parentheses, and close with a semicolon. So it's supposed to print out 5, since we have 5 different characters. Okay, so let's try something else. For example, if I wanted to say Kathy likes bananas. A very random example. So here we have Kathy, which is 5, But the thing about strings and the thing about characters is that the space over here is also considered a character, which means it will be given a specific index. So we start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. I hope I counted that right. But the point here is to show you that spaces, oh, so it's 19. I counted that wrong. I'm sorry. Spaces also are characters and they do get their own index, okay? So the first function we learned is the dot length function. In this case, we say name dot length since we want to relate it to a specific string. And the length or the size, you can also use size, it would give us the same exact result, would basically give us the number of characters inside a specific string, okay? So I know we're digging quickly into the questions, but I want us to practice. I want us to practice these concepts. Like I want us to basically practice and warm up since we have different questions that we want to solve today. So with word capitalization, we get a specific string, okay? And all we have to do is make sure that the first one remains unchanged if it is capitalized. So here, even though there are a bunch of upper and lowercase letters, we are only concerned with the first element in the name array. Okay, so the first element here is capitalized, so all we have to do is simply just print it as it is. However, in the second test case, K, which is the first element in this string, is not capitalized, meaning we have to capitalize it since this is the whole point of the code. Okay, and the length of the word will not exceed 10 to the power of 3. So now all we have to do is simply declare a string, call it word, for example. You can call it absolutely anything you want. And they mentioned that the length of the word will not exceed 10 to the power of 3. So technically we do not, with strings, we do not open square brackets. But here we need to receive the string from the user, okay? So what would be our next step? How exactly do we receive the string from the user? And by the way, you can also solve this using a character array. But what you have to do is that with character arrays and with arrays in general, you always have to give them an initial value, meaning with the character array, if you want to start with car word, the max value would be 10 to the power 3. So you'd have to include 10 to the power 3. Okay, but strings make it a lot easier since they basically function the same exact way as any other array. So with string word, how do you think we should start? So first we need to receive the string from the user. So what would be our first step?
C in word.
C in word, perfect. Okay, so what would be our next step? Since over here we are only concerned with the first element of the string. So in this case, do we need a for loop, for example?
No.
No, we don't need a for loop, right? So, because we're only concerned with the first element. And the first element has the index of 0. So what do you think? The problem is asking us, if it is capitalized, print it as is. If it's not capitalized, make sure to capitalize it. And we did the same exact thing in the previous example. What do you think would be our second step?
We need to use an if statement. So
okay,
if word 1 or 0, I mean. Okay. They want it capitalized.
Yes, they want it capitalized. So what do you think?
Okay. Is less than. A.
Less than or equal, right?
Yeah.
Small a, perfect, Yasmin. Yes.
Okay. And
yes.
Word 0.
Yeah.
Is less than or equal to Z.
Oh yeah, perfect.
Greater than.
Is it greater? I think I messed up over here. So from A to Z, but Z is going to be way greater than A. Okay, so A is always less than, and Z is always greater than or equal. So that's my bad. I messed it up, but this is perfect. Okay, so in the case that
I think we have written both greater than.
yes, we have. Thank you, Zaha. So in this case, if the first index, if the first element in the string is a lowercase letter, we have to capitalize it. So what did we say about that? How do we capitalize? What do you think?
Word 0 minus equals 32.
Perfect. Minus equals 32. Absolutely. Oh, yeah, 100%. This is perfect. So all we did was receive the word from the user. We check if the first element is not capitalized, make sure to capitalize it. And Zaha is spot on when she said minus equals, and that's because capital letters, again, are smaller than lowercase letters, and hence we used minus equals. Perfect. Okay, so we made sure that the first letter is capitalized. What would be our next step? It's the easiest part. What do you think?
The outward.
See outward. Absolutely. So let's try with the test cases. Let's try with the first one. Oh, I'm gonna try to use the text over here and include Apple and see how it goes. Come on, GTP is not cooperating today. Let's try to run the code and see. So it's gonna print out Apple, right? Because the first element, which we called word of index 0, is already capitalized. Let's try with the second word and see. Go back to input, print that, and we run the code and see what the code gives us when we run it. Awesome. So it capitalized K, since K over here was lowercase. Perfect. So all we have to do now is simply just copy paste our code, go to submit code, and choose our problem, which in this case is word capitalization, print, and submit. Okay, let's wait and see. It's oddly taking some time. Maybe it has to do with my internet. I'm not quite sure. But regardless, our work it's a very, very simple problem. All we basically did was simply just check the first element as they mentioned and as they asked for. We check if it's less than or greater than A, or greater than, sorry, or equal to A, or less than or equal to Z. Then we have to capitalize it, meaning we have to decrease its value. I'm not sure why it's taking too much time. Let's try to refresh. I'm sorry about that. Okay, I'm gonna try to submit the code again. And if it doesn't cooperate, we'll just move on. It's not a big deal. Okay, that's fine. Okay, we'll get back to it later. So basically, our code is correct. We checked with 2 different cases, and it's a very, very simple code. But before we actually start solving different examples, I actually want us to get a little more familiar with different string functions that can help us. And again, we will be talking about functions later on in the course, maybe next time or in 2 weeks, because functions are very, very important, and we'll talk about why they are important when we get to them. But I want us to introduce two different functions. We might not necessarily use them today, but it's good to know all these basic functions in case you needed them later on whenever you're writing a piece of code. So we're going to stick with string word, okay, and I'm going to give it an initial value of, why do I keep adding these? I'm going to give it an initial value of, for example, yellow is great. Anything, literally, or yellow is my favorite color, or any. You can just give your string anything, whatever. For the sake of demonstration, we're just gonna stick with yellow is great. So the second function I want to introduce is basically the find function. Now the find function with strings actually helps us figure out where a specific word or where a specific phrase or where a specific anything starts within the string. So for example, I want us to look for is in this string. In order for me to find the word is, I have to, of course, include or relate it to a specific string, and I want to see out what we find and include find into parentheses. Now, the thing about the find function is that it takes two parameters or two arguments, and we will be talking about these later on. But parameters for now, so basically when we say it takes two parameters, it means it takes two different values. And the first value would be the string that we want to find. So for example, here, I want us to find is, okay? And the second parameter includes where we want to start in the string. So where do we want to start searching for the specific phrase in this entire string? So I'm going to go with the beginning of the string and give it the index 0, okay? So the first parameter is the word or the phrase or even the letter or the two letters that you want to find. And the second parameter includes the index of where you want to start, okay? So I want us to see what the program will actually give us when we run the code. So all we did here is use the find function, give it two parameters, and of course relate it to a specific string, which is the word string, okay? Let's see what it gives us. So it's gonna give us 7. Okay, so what exactly is that 7? So we decided that we want to start searching from the first element, which is index 0. So we're gonna start searching from here. 0, 1, 2, 3, 4, 5, 6, and 7. So is starts on the 7th index, okay? So what we have to know for now is that find basically helps us find a specific phrase or string within a string, and it takes two parameters and it returns an integer value, and that integer value is where that string starts, okay? So for example, if you want to try great, it's of course going to give us a different value. Let's see what it gives us. It's going to give us 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. The word great starts from the 10th index. Okay? So this is an easy function. I want us to go with another function called substring, but for short, we go with substr. Now, substring, basically, the substring function also takes two parameters, but these parameters are two different integers. So let's start with string color, or let's start with string phrase, and give it the value of TechGirls Programming Club. It's a long string, but let's stick with that for now. Okay, so here's the thing about substrings. Substring, we're going to be giving it two different parameters, but the substring will be printing a specific word. So find will be returning an integer, which is where this string starts in this large string, but the substring is basically going to give us a string. And how do we find that string? For example, you want to use a substring to print out programming or to print out club, and you know that programming or club is in this string. So in order for us to print it out, we say we say phrase, since here we are relating it to this string, we're working with this string, sub str, and we're going to give it two different parameters, but this time the parameters are going to be integers. So the first parameter is going to be where we're going to be where we're going to start looking. So for example, with TechGirls Programming Club, we are going to be starting from and for example, we're going to be looking for programming. We're going to be starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, because we know that programming is over here. So we're going to be starting with 10, and programming is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 10 letters. It consists of 10 letters. So if we want to save programming, or if we want to print out programming on its own, all we have to do is start with the first index, which is apparently, as we counted, is index number 10, and go on 10 steps, since programming consists of 10 different characters. I hope this isn't very confusing, but and you don't necessarily need to use these functions, but they really ease the process for you, and they're built-in functions in C++. So the substring function basically just prints out a specific string within a string. So it prints out a substring within an even larger string. And we're going to try to actually see out. So I'm going to remove this for now. Okay, I'm going to stick with substring. If I counted right, it's supposed to print programming. So I did not count right. We are going to start. I forgot the last G. Apparently programming is 11 letters. It's going to print programming. And the thing about substring is that you can save it in a different string. For example, string, I'm going to call it sub. And then you can see out sub. And it would give you programming. Okay? So let's see. All I did was just save the value here in a different string and see out that string. Okay, so basically, the find function, all it does is find where that string begins in this string, okay? And the substring function basically helps us print out or save a specific substring within a bigger string. Okay, do you have any questions? I hope I didn't confuse you girls. But you don't necessarily need to always use them, but they're basic functions, and it's good to always know about these functions in case you come across a code that where these functions would actually help you figure out the solution. Okay, so for example, if we wanted club, and club is 4 words, we would have to go with 4, since we're moving 4 steps, but we have to start with the index of C. I'm gonna have to count all of them. So let's just remove TechGirls and go with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and it's on the 10th. It's on the 10th index. I shouldn't have counted again. It's obvious, but that's fine. So what it's gonna see out now is club. So I kept the see out statement from before, but let's just focus on club over here. Okay, so these are basically the functions I wanted to talk about. So we talked about the function, the find function, the substring function, and the length function. And the length function basically gives us the number of characters in a string. Find function helps us determine where this string starts within a greater string. And then the substring function helps us print out a substring within a bigger string. Okay, do you have any questions before we move on to some practice questions to solidify our knowledge in strings? If you have any questions, please feel free to ask. Okay, so I think we're good. We are going to start with some warm-up questions, and then at the end of the session, we are going to try to solve a really fun Code Forces question that I hope we can have enough time to solve by the end of the session. So, working with strings, I want you guys to help me print out, and this is an easy one, we did it last time. I want you guys to help me print out the reverse, the string in reverse. So for example, I'm going to reassign, and then we're going to try to receive the string from the user. I'm going to reassign name and give it Kathy another time. I'm going to give it Kathy again. And now I want us to print Kathy in reverse. So using one of the functions that we talked about in a bit, how do you think I can formulate my for loop? Let's start with the for loop first. What do you think?
For int I equal to 0.
For int I equals to 0.
Okay, I is less than.
Oh, okay. So I want us to print Kathy in reverse. Do I start from 0?
No. Okay, I is equal to name.length.
Name.length, absolutely. Name.length, 100%. Okay. We're gonna fix this, but let's go with it. Name.length is a great start. So what do we go with next?
-1.
-1, perfect. You caught it real fast. So why is it -1, Yasmin? Why do you think?
Because you told us that the indexes are always less than the length by 1.
Absolutely.
So there's no, so let's say like Kathy is 1, 2, is like 5. The length of it is 5. However, its index is 4. So when we say I equal to name.length, it's gonna give us 5, and there's no index 5.
100%. Excellent, Yasmin. Perfect. And you caught it real fast. I'm really happy that you did that. So we can't keep name.length because we don't have an index that has the value of 5. We only have index values from 0, 1, 2, 3, 4, up to 4. Y is the last index, which has the index of 4. Perfect, Yasmin. Okay, so I want you to help me continue the for loop. What do you think?
Okay, I is greater than or equal to 0.
Perfect.
I minus.
Absolutely. And all I want us to do is simply see out or print the string in reverse. So what do you think?
See out name I.
100%. Okay, let's see. Let's run our code and test it. See what it gives us. It's kind of odd. It looks pretty odd, but that's basically the string in reverse. Okay, what if I wanted to receive the string from a user? Just one extra step. What do you think that is?
CN string.
CN string?
Greater than name.
Name. Perfect. Absolutely. So we are going to ask the user to enter. And we usually prompt the user to enter, but for now, the compiler is waiting for us to enter. I'm going to go with Haya, for example. It's going to print Haya in reverse. Awesome. Okay, so this is our first warm-up question. Okay, so what if I'm going to keep C in name? Okay, what if I wanted to convert uppercase letters to lowercase letters and vice versa? That's a tricky question, but we talked about it and it should be easy. So for example, if name was, and I'm going to comment this out, if name was F-A-R-A-H, I want our program to print F-A-R-A-H. I want it to reverse uppercase into lowercase and lowercase into uppercase. So what do you think? What do you think would be our first step?
We use a for loop first.
Perfect.
Okay, we start I equal to 0 and I equal to 0. Okay, I less than name dot length.
Perfect.
I plus plus.
I plus plus. Okay. What's next?
Okay, we have two conditions. First, if name I
Yes.
is greater than or equal to a, small a. And,
Okay.
okay, name I is less than or equal to z.
Oh, sorry. Z. Perfect. That's a tricky part. What do you think? So we want to convert it to uppercase. And uppercase, here's a hint. It's always smaller than lowercase letters. What do you think?
Okay, so name I minus equal 32.
Absolutely. Minus equals 32. And again, 32 is the difference between an uppercase and lowercase letter. Okay, so we can just go with else, right? Or we can go with else if, but since it's either
Else
that,
is easier.
else is easier, right? Yeah, and it's more efficient. So else.
Name I plus equal 32.
100%. Perfect. Okay, so what would be our last step? We want to display to the user.
See out name.
See out name. So I'm going to add just an extra note here. Name in reverse. Oops. Name in reverse, and then we are going to see out. Oh, sorry,
I think
reverse.
we wrote 2 instead of 32 in the else.
Yes, that's true. Thank you, Zaha. What did I do without you girls? So name in, I don't know. Is it reverse? What is it? Name, I don't know. I'm just gonna keep it as name, okay, for now. If you have any suggestions, let me know. We're gonna stick with name for now and see how the code works when we run it. Okay, so it's waiting for us to enter. So I'm gonna try to enter different loops. So there you have it. From upper to lower, lower to upper, upper to lower, and last, the last element is a lowercase, so it converted it to upper. Okay? Okay, so I want us to solve one more thing before we move on to the code forces questions. And this is a slightly tricky question, but we're gonna solve it together. So the last warm-up question for the day, and I'm gonna keep this just so we don't keep on writing the for loop again and again. I want us, and there's a tricky detail, okay, that we mentioned before, but I want to see who keeps up. I want us to receive a string from a user, and keep in mind, the string can have more than one word. And I want us to see out the number of words in that string. So for example, if the string, I'm going to comment out CN for now. If string name had, my name is Farah, I want our code to print out 4. Since we have 4 words, 1, 2, 3, and 4. And it's guaranteed that the user will enter at least 1 word. Okay, let's just make it a little easier. So it's guaranteed that the user will enter at least 1 word, but I want our program to figure out how many words are in this string entered by the user. Okay, any ideas? What do you think?
First, we need a counter.
Perfect. Yes, that's a perfect step. Int counter. So what do you think? What do you think I should initialize my counter? How do you think I should initialize
0.
it? 0. Okay, so let's go with 0 for now and see where it takes us. Let's stick with 0.
I think
okay?
it would be better if it's 1 because, as you just said, we are starting with 1, or we have at least 1 word.
100%. So we do at least have 1 word. So our counter should start from 1. Okay, but I want us to stick with 0 for now, just so we can test our code, but 1 is great. So because I told you girls that it is guaranteed that the user will enter at least 1 word, the counter will start with 1. Okay, so do you remember when we talked about strings and how we receive strings from the user? What do you guys remember when we mentioned that? And these were like, I think this was like a couple of weeks ago. So what do you remember? Is CN name enough?
There's the get line.
Yeah, so why do you think we should use get line?
Because after the space, I think it does not like take it.
Yes, 100%. Here's the thing about strings. When you see in string like that, okay, at some point when you click enter, when you click enter or the space bar, it's going to completely disregard everything to the right and only take the first string that you entered. But in this case, this isn't enough because we're counting the number of words. So excellent. We need to use get line. And do you remember the format of get line?
CN, comma.
CN, comma.
Name.
Name. Perfect. So we CN the variable, the string variable that we called name. Okay. So on to the tricky part. What do you think? How can we figure it out? How do we figure out how many words we have in a specific string, which in this case would be a sentence or a word minimum? What do you think?
Okay, if name I is
If name I. Okay.
Is equals to equal the space.
The space, perfect. So we said that the space is actually a character, right? It has its own index. Excellent. So if name I is a space, what does that mean?
Counter plus plus.
Counter plus plus. Excellent. Perfect. So, and the last step would be to number of words. What would be our last step? See out the counter, right? So that's all we have to do. Okay, so let's run through the code again. We have the string name and we set a counter. Since the purpose of this piece of code is to count how many words we have in a specific string. We use the get line statement because with CN name, we only get one string, or we only get the string, the first string that the user inputs, or the first string that we receive from the user. But with get line, we get everything the user inputs until they press enter. And here, since we mentioned that space is actually a character, all we have to do is declare this space, or like declare that there is more than one word, and we increase our counter. Perfect. A very simple code. And let's go with Farah loves C++. Oops. So I forgot the Farah, but that's fine. Number of words is 3. And for example, if we started the counter from 0, the compiler would give us a different answer. So for example, TechGirls Programming Club, compiler is going to give us 2 words, although we have 3. So because at least we're going to have 1 word, we should start the counter from 1. So we don't always necessarily need to start the counter from 0, but we do need to understand the requirements, and we do need to understand what the code is asking us to do. Okay, so are you ready to move on to the code forces question?
I have a question.
Yeah, go for it, Akid.
So what if by mistake I put like a word and then a space? What would it?
Oh, you mean like 2 spaces?
For example, I wrote Zaha and then a space and then enter. Like I won't write
Oh.
anything else after that.
Yeah, so that's gonna be it. That's gonna give us an error, right? It's not gonna give us an error, but it's gonna give us invalid results, right? Since if you include Zaha, for example, and enter space, it is let's try that. It's gonna give us 2 words. That's 100% true. So this is a great question, Zaha. I want you girls, and it's a tricky question, but you can solve it. I'm pretty sure you can. I want you girls to figure out a way to make sure that even if the user actually messes up and includes an extra space, I need to make sure that it's 1 word, since they did not include anything after Zaha, for example. So it's a tricky one. And that's a great question, Zaha. And I want you girls to try to figure it out. And I want to see solutions. Okay? It's an extra step that you need to do. It's an extra step that you need to write the code for. So here, we only included 1 word, but because we included an extra space, it gives us 2 words. So how can I fix this? Okay? And if we get the chance, we can talk about this next in our next session. But for now, because we don't have a lot of time, I want us to move on to way too long words. Okay, so way too long words is a really fun example, and I want to solve it. I want us to solve it together. So sometimes some words like localization or internationalization are so long that writing them many times in one text is quite tiresome. Let's consider a word too long if its length is strictly more than 10 characters. All too long words should be replaced with a special abbreviation. Okay? So the abbreviation is made like this. We write down the first and last letter of a word, and between them, we write the number of letters between the first and the last letters. So they give us an example. So localization is 12 letters, okay, which is strictly more than 10. So with localization, we print out the first letter, which is L. We print out the number of letters or characters between the first and the last letter, which is 10. And we print out N, which is the last letter. And with internationalization, which consists of 20 letters, we print out the first letter, which is I, 18, which are between I and N, the number of letters between I and N, and then the last letter, which is N. Okay, so you are suggested to automate the process of changing words with abbreviations. At that, all too long words should be replaced by the abbreviation, and the words that are not too long should not undergo any changes. Okay, so here we have word, we have localization, we have internationalization, and then we have this huge word that I do not know how to pronounce. So word is less than 10 is less than 10 characters. So if we are only allowed to have up to 10 characters in order for us to not modify anything. So because word is less than or equal to 10 characters, we will print it out as it is. However, as we saw before, localization has to be printed out like that, and so does internationalization, and so does the last word. Okay? So I want us to try to solve this together. What do you think would be our first step? So I'm gonna start with the first step, which is string word, for example. I want you to help me now. What would be our next step? Girls, what would be our next step? What do you think? There's something else that we need to add, right? The first line contains an integer, and each of the following n lines contain 1 word. So I made it easy. I started with a string word, but there's something else we need to include, something else in the input. What could that be? Int n, sure. Perfect. Okay, what would be our next step? What do we receive first?
The integer.
Integer, 100%. So C and N. Okay, so here's the tricky part. What do we do now? What do you think?
I think we
So
should
we are-
include a for loop.
100% for
Int I equals 0.
mm-hmm.
And then I is less than or equal to n.
So do we say less than or equal to n or less than n? Because if we say less than or equal to n, it's going to go from 0 to n, which is an extra step.
Yes, so that's
Right? Yeah, or we can just say 1 I is less than or equal to n. It doesn't matter, but for now this is great. And
I plus plus.
I plus plus, awesome. Okay, so we are going to be receiving the string word n times. So where do we receive string? Where do we ask for it from the user?
Inside the for loop.
Mm-hmm. So
Cn word.
Cn word. Perfect. Now this is officially the tricky part, but we are going to be using one of the functions that we actually practiced multiple times. So what do you think? The first word is less than 10. Do we modify it? Less than or equal to 10? Do we modify it if it's less than or equal to 10?
No.
No. So what do we say?
If word is less than, no, I mean if word dot length,
Perfect. If word dot length,
okay, is less than or equal to 10, see out word.
see out word. Perfect. Okay, what if it wasn't? Like internationalization and localization. Else? Let's see. It's a tricky one, but we can get it. So what did they ask us to do? They asked us to print the first letter and then the number of letters between the first and the last letter, and then the last letter. So L, 10, and N, meaning localization has 12 words, has 12 words, has 12 characters or 12 letters. So how can we translate that into code? What do you think? What's our first step? Our first step, what is it?
To write the first letter.
We write the first letter. So how do we write the first letter?
See out word 0.
See out word 0. Perfect. Okay. I'm going to keep them on the same line, although you can include multiple see out statements, but I'm going to keep them on the same line. So see out 0. Okay. And what's this? How do we find this? That's in the middle.
It's word dot length minus 2.
Absolutely. Word dot length minus 2. And that's because we're printing the first and the last letter. So we are only printing the remaining letters. So it's basically length minus 2. And the last one?
It's word brackets word dot length minus
Word
1.
dot length minus 1. Excellent. Okay. Let's see what it gives us. Are you ready to test the code? Let's copy. Let's see what it gives us. Oh, so we have to, what do you think we should do? Why are they next to each other?
End line.
End line, exactly. So I'm going to include end line here, but it's basically working. It's just kind of messy. Oh, and we also have to include end line here. Let's try one last time. I keep forgetting these details, and you girls always help me with that, so thank you. Let's see. So word, excellent. L, 10, N, Excellent. I 18N and P 43 and S. Excellent. Perfect. Okay, so let's try to copy our code and try to submit it on Code Forces. And I hope it doesn't give us a lot of trouble now. Let's try to do that. Okay. Oh, and by the way, it accepted our code. It took it ages, but that's fine. It's running and running and running. It's taking a lot of time, but that's fine. So until we get our result, does anyone have any questions about our code? Anything? So the thing about these functions is that you can literally use them anywhere. You can store word.length in another integer size, and you can use it here and you can use it wherever you want. So instead of having all of this, and maybe in some codes, you might need to use the length multiple times, or you might need to use the size of the string multiple times, you can just store it somewhere instead of having to write all of this all over again. But so here we go, our code is accepted. So this is the cool thing about functions, is that they help us out and they ease the process for the programmer. Excellent, girls. Honestly, you were absolutely amazing, and I did not expect us to get it that fast. And that's great. So I'm going to stop sharing, and